nice to meet you. So for those that I don't know, nice to see you again. For people that were there last year or the year before that, I'm very happy to have you there today. 1 year of Haxe. So, what we did this year, what happened this year, what we are doing to do next. So last year, at the same, not the same room, it was a different room, but at the same place, we had this great conference. We made several announcements. We made a 3.0 release that I hope all of you are using. We're still on 2.10 there. Nobody? Perfect. Okay. And we moved to GitHub, which was a bold move for us. It really changed a lot of things and really helped us, by the way. We are very happy with this. We announced the first X Foundation partners that were helping us fund like different projects we are doing. And what did it then? Then we made this year we made around 2,300 commits, which is a lot of work. We released a 3.1 in March after a lot of. I will introduce what we did there. Followed quickly by a 3.1.1 and a 3.1.2 and sadly a 3.1.3, which are bug fix release because Haxe is becoming so much, doing so much things, becoming so much huge that we had to small regressions, not big ones actually, really concerning a very small percentage of users, maybe 1 or 2 users actually reported things, but we wanted to first make sure that they were perfect released before working on 2.2, 3.2, which we are doing now. 3.1. It's an update on 3.2. The idea is that we, as much as possible, we are not to, we are on the 3 all the 3 timeline we will release. We are trying not to introduce any breaking change. We are trying to be as much stable as possible. Before, in previous 2.1, 2, 3, up to 10 release of Haxe, it was every release was introduced breaking change because the language was evolving, the standard library that was evolving. We were like changing a lot of stuff and improving a lot of stuff. So it was sometimes very difficult for people to cope with the change. If we are on 2.5 and trying to upgrade to 2.7 was a lot of different things changing. So, but since 3.0, our goal is to have a really high level of stability in the API, in the language, everything. Of course, sometimes we fix bugs and it introduces regressions in the way that code that was maybe accepted is rejected. But sometimes it's actually unable to fix bugs in the code itself. So it's nice as well. We are improving in 3.1. We improved like features that we have introduced in 3.0, such as pattern matching or abstract. There were new features in 3.0, so of course we had bug reports. We have a suggestion to improve things, to support more things, more features in that things. So things on speed. We had a very bit of additional syntax. Not so much. We don't want to have the language growing in terms of syntax and becoming so much like horrible beasts. Additional things to the standard library that we keep completing. And of course, various fixes and optimizations. And some of them were big ones. I will show you that afterwards. New things in pattern matchings. In 3.1, we introduced something called extractors. Who knows about extractors here? 1, 3, maybe 4? Okay, it's nice to present it. Okay. Extractors is a way to, who use pattern matching, you know, like not only switch on values, but actual pattern matching on enums. A lot of people. Yeah, raise your hand, please. Okay. A lot of people use pattern matching. Sometimes when you match a pattern, you are matching against something that is not really computable. It has to be someone like an enum, a value or something. But what if you want to introduce function call and user code in your pattern to make sure it matches correctly? That's what extractors are for. So 2 examples here. If you switch a string value, you can use the underscore here is a special value to say this is the value that get passed to the function call. So here you can say underscore 2 lowercase the arrow is to say it returns or it matches the value foo. It's not about a value because on the right side it's a pattern, okay, of the arrow. So you can put any pattern, okay. So here the pattern is a string, constant string value, but it could be something that is an enum and have like something much more complex. And you can also introduce user functions, such as the no space functions, which I'm declaring there, which checks that removes the space. And there you bind on the right side of the arrow, you bind it to the x value, and you check if x different is not empty, then you return x. It's a bit maybe complex to understand for people that don't use pattern matching, but the idea is that basically it allows you to define custom function in pattern matching. So it's pretty powerful. And we are also allowed to match the null value in patterns in 3.0, which was not possible before for implementation details. Abstract enums. Who use enums there? Here. Well, good. Sometimes, at first, we introduce enums, which are some kind of very high-level constructor in Haxe. You can do a lot of things with enums, which is pretty nice. You can have parameters, it can be recursive, you can have reflection on it. But sometimes some people want something much more low-level, actually like enums in other language, especially for interacting with given native platforms enums. That's why we introduce abstract enums, which are actually just macros that runs on the abstract. The idea is that you declare an enum abstract this way. So we have not yet, maybe we have that in 4.0 kind of real syntax for it. So right now we're using metadata for that to tag the abstract. So you declare metadata enum abstract, the name of your type, and the type, which is an underlying type in the abstract definition, which is what are the actual values that are in the manipulated. And then you declare variables. And it will really act as an enum, which means that when you switch on it, it will complain if you don't have some cases that are unmatched. It is real type, which is it has a type of A, and if you try to assign a string or to assign it to the string, it will not work. So it's really a type of its own, okay? It behaves exactly, or type-wise, so in terms of compilation, it behaves exactly like an enum. But it's only restricted to a set of runtime values, okay? It's not the drawback, of course, is that you can't have a reflection on this. I mean, not like enums that you can list the constructor and everything. And you can, of course, you can have parameters, like values that are captured and everything. That's a good trade-off. The new syntax we introduced in 3.1 is this. It's a way to specify that the expression is of a given type. So here we have a variable, then we give an expression, and we use double dot type. So this is exactly the same of saying var f type equal expression. It will do the same check somehow. It will check that the expression is of the given type. So one usage of that, there are several usages of that, in particular in macros, but one usage of that is, for instance, let's say you are using that. You are using reflection to set the field of the object. You set the field name, and you want to ensure that in case you change your foo function, you will get an error because you want to be sure that the foo function returns a string. So if you write this, it will ensure that it will print you a compiler time error if the function is not a string. It will say, for example, if foo returns an int, it will say int should be string, okay? But if you don't write this, it will accept anything because reflect set field accept any value as a field value, okay? So this is kind of usage you can make for it. So it's ensure that the expression is of the given type. It can be sometimes nice if you want to, especially if you have something that returns dynamic. This way you infer exactly the types you want, and you don't have to store it into a variable that is typed before using this variable. It's kind of self-declaration. Actually, this thing was introduced first in macros to the echeck type expression. And since it was quite useful, we decided to have actual concrete syntax for it. And we thought that the syntax is quite fit nice in the language. And value.match. So that's something new in 3.1 as well. The idea is that if you want to quickly match an enum, you can use my_enum.match pattern. For instance, if macro x.max expression is indent, then this. Okay? So you see what is in parentheses is not an expression. It's a pattern. Okay? And it's a short version of the switch. It only returns a bool result, which is it matched or is it not? Of course, the drawback is that you can't capture values. It means that if I want to know which indent is matched, or to get it back, I have to use a switch for that. STD instance. Who knows about STD instance here? 3 people, 4 people. Oh, I really, it's nice to see people that I can learn new things. Sometimes the people, they know everybody about everything I'm speaking about, but this time it's nice to teach. This is signature of the instance function. So it's a bit complex. Let's go through it. STD instance is a function that takes 2 type parameters. A T type parameters, which has a constraint to be an object, which is the empty object, the empty structure here. And the S parameters, we can constraint itself by T. Okay? And then it takes a value of type T and a class of type, and another value of type class of S and returns S. So what does it do? What does it do? Does somebody know? No? So basically, you give him a value and you give him a class, and it returns, it will cast this value to this class if it's matched type. So let's look at it in a more proper example. You have a class A, you have a class B extends A, and you have a class C which is entirely not related. You create a new B, and you assign it to a value which is, so you restrict it to be A. Sometimes happens, you have a lot of hierarchical things, and you happen to kind of reduce the type to the common type, okay? But sometimes you want to actually get the actual real type of the value, the subclass somehow, because you want to check maybe if it's actually a B or not, because it can be a B, it can be a B, it can be something else. It's not a C, you know for sure, because it's typed as A. Okay. So with STD instance, you can check if A is B. If it's a B, it will return the value itself, but typed as B. Okay. So you will have actually the value, but you can access the B fields. If it's not a B, for example, if it's an A or if it's a D that also extends B or extends A, sorry, if it extends B, it's worse, then you will return null. Okay, so it's a way to say I want to somehow downcast. If you look at the type hierarchy, when you move from B to A, you are upcasting. Upcasting is always safe because you're just moving up in the type hierarchy. And downcasting is not safe because you don't know in advance if it will be the type you're downcasting to. So STD instance is a safe downcast because it will return null if it doesn't work and return as much as it can be. And of course, if you're stating with C, you will get a compile time error, which is good because it can't possibly be a C. And this is ensured by the constraints, because if you look at the constraints again, you will see that the class we are using has to be constrained as being a superclass of the parameter we are passing to. Okay? Makes sense? So this was a good example to show what you can do with constraints. Okay? So first, we see two things. It's constrained to be an object. So it means you cannot use int or basic types or those kind of things. It's also good for us because it enables us to kind of optimize the function to work only on object. We don't have to check all the case with basic types. It's also quite safe. So it's optimized. There is no basic stuff support. It's maybe optimized on all platforms. I don't know about CPP, for example. Maybe optimized, or maybe it will be optimized. It's used like for quick downcast. Okay. Just a small story of the kind of optimization we made in 3.0, in 3.1, sorry. Compiler cache memory. That was a hard one. I want to tell you the whole story of it because it's quite funny. The idea is that we get a report for one of our X Foundation partners. We say, oh, compiler cache takes too much memory, and we are talking about gigabytes of memory. Okay. So we say, okay, this is we need to help that. We need to fix that. Okay. Who knows about compiler cache? I will explain again. Compiler cache is a way when you can run an X compiler server, and when you compile something, it will compile with the server and cache the results, which is on the next compilation, it will only compile the things that have been changed, the modules that have been changed, which makes things very, very fast. So if you have actually an issue with your compilation time code, if you have issue with compilation time, use the compiler cache, and it's really very powerful. It will really speed up maybe 10 or 20 times depending on your. If you use a lot of libraries, especially that are not related to your code and doesn't get modified, compiler cache will really, really speed up the compilation time. So we have this great compiler cache, and we have a problem. It takes too much memory. Okay. So things I did, first thing is to get the tools to investigate the situation. So I had something which is called a display memory, which is kind of, you can try it at home. It's redumped, so you use it, you connect to the compilation server with x.-- and the port of the server. Then you use display memory, and it will print the cache size and the module reference. For every module in the cache, it will print how much memory it takes, and it then will print all the modules reference between each other. Okay. So for instance, this module uses this module. So it's a lot of dump, a lot of data, especially if you have big projects, but you can see if things go wrong. So at this time, we noticed that there were some kind of leaks. A leak in that case is, for instance, module A get modified, and then it's recompiled, but some modules are still pointing to the old version of A, which they should not. So actually, it was not causing any bug because it was just referencing the module without actually using any type or something. So it was not breaking because it was already correct in that area, but it was still having a reference to the module, which means it was keeping the old version and the new version in memory. And if you keep growing, you have several versions in memory, and it kind of makes memory grow. So we fix that, and we say, okay, it's fixed, good. Try it again. And then a report came. We fix all things we fix, and we use display memory, and we have one single module that takes 2 GB of memory. I say, oops, there must be something particular with this module that just doesn't work. So it was good because it was quite, so the module was quite private code. So they sent it to me, and I look at it. It was a very one big file. I think it was a few thousand lines with a lot of mynum.value access. A lot of these things, a lot, really. It was a typical corner case. And I was thinking, why it takes so much time? It's quite simple code, actually. It was just a big switch and a lot of my-value access. So we look at the compiler, and we investigate different things. And finally, we found the culprit. It was every time we are doing not mynum.value access, if we are importing mynum, it was not a problem. You could access value directly. Okay? But if you are doing mynum.value access, when you are typing mynum, it was making a copy of all it was creating an anonymous type, a structure, with a copy of all the fields of the enum. And actually, the enum was pretty big. It has like thousands of cases. So it was some generate code of like error message. I don't remember exactly, but and it has thousands of cases, and it was making a copy every time you're doing an access of this. So it was thousands done thousands times. So it was really taking a lot of memory. So we fixed it, and the nice thing is that so it reduced 200 times the memory took by the model, which was good. And I think 200 is for the whole compilation thing. Well, it's quite good. And then actually it was also speed up a lot of the compilation. And not only the compilation of this particular module, but the compilation, I think on some project of mine that was using some of them, my value access, I think I just got to 10 or 20% speed up just for this fix. That's like, oh, that's good investigation. So that's the kind of things we do, like out of fun.